Hello students, welcome to our channel ADDED. Myself Akshay Singh. Here I am going to teach chemistry for NEET JEE. Today we are going to learn chapter chemical bonding. First of all, what is meant by chemical bond and what is meant by bond? We are going to learn one by one. First of all, definition: chemical bond. Chemical bond means it is the force of attraction between the molecules or atoms which holds together. Force of attraction between atoms or molecules that holds together is called chemical bond. Here in chemical bond there are different types of bond. For example, ionic bond, covalent bond, metallic bond, coordinate bond. Let's learn one by one. First of all, ionic bond. Here example for ionic bond: sodium which reacts with chlorine, it will form sodium chloride, which is in solid phase. Chlorine will be in gaseous state, sodium in solid state. Here sodium is metal and chlorine is non-metal. Here the bond present between sodium and chloride, that is ionic bond. Here metal will donate electrons and non-metal will accept electrons. Metal will donate electrons, non-metal will accept the electrons and form a compound called ionic compound. This is how ionic bond is defined. Okay, second type. Covalent bond. Example, H2. Here between two hydrogen atoms, the bond which is present is occurred by sharing of two electrons. One hydrogen atom will share one electron, another one hydrogen atom will share another one electron, and the bond which is formed by mutual sharing of electrons. Mutual sharing of electrons is called covalent bond. Mutual sharing of electrons is called covalent bond. Third one, metallic bond. We already know that metals have the property to donate electrons and non-metal will accept electrons. Here metallic bond, for example, two metals are there, it will donate electrons. This metal will donate in this direction, this in this direction, and the bond present in between is called metallic bond. This is how the different types of bond: ionic bond, covalent bond, and metallic bond. Another one, coordinate bond. In coordinate bond, one atom will donate two pairs of electrons. For example, like this, it will donate two pairs of electrons to this. This is the definition of coordinate covalent bond. Now we are going to learn causes for bonding. Causes for bonding in between molecules. First of all, atom. Atom is a small indivisible particle which cannot be further divided. That is called atom. And two atoms combines means two atom. For example, A with atom 1, B with atom 2. If two atoms combines means it can form molecule. It will form molecule. And now we are going to learn what are the reasons to the formation of the molecule. It has three different theories. First one, valence bond theory, valence shell electron pair repulsion theory, molecular orbital theory. Valence bond theory, valence shell electron pair repulsion theory, molecular orbital theory. We have three types of theories to explain molecular formation. Let's learn one by one. And another one, Kessel-Lewis approach. First, we are going to start Kessel-Lewis approach and determine how the structure has been formed. First, in Bohr's model, we have learned that central part is nucleus which has protons plus neutrons, and electrons will be revolving around the nucleus in a fixed orbit. This is according to the Bohr's theory. But here, for example, sodium, we have taken example sodium. For sodium element, let sodium be inside the shell, and the electrons which are sodium having totally 11 electrons, that is atomic number 11. So 11 electrons, atomic number 11. So 11 electrons. So this is the Lewis representation of sodium atom. See here, the electron which is present in the outermost shell, last shell, they are called as valence shell. Valence shell electrons, and remaining part, other than that, he named it as kernel. The electrons which are present in the outermost shell or last shell, they are called as valence shell electrons, and the remaining part, other than that, is called as kernel. This is according to the Kessel-Lewis approach, and we are going to learn Lewis representation. It has total 4 rules for Lewis representation. Rule number 1. Identify electronegative atom. Identify the electronegative atom. First, second point, less electronegative atom. Less electronegative atom should be written in center. First we need to identify electronegative atom, then we are going to write less electronegative atom in the center. Then third rule, distribute number of electrons based on octet rule. Based on octet rule, and central metal atom should satisfy octet rule. These are the 4 rules for Lewis representation. And first of all, octet rule. Octet rule. Octet means it should have 8 electrons, mainly noble gases. Noble gases like helium, neon, argon, krypton, xenon are the noble gases. Some noble gases, they will have out 8 electrons, 8 valence electrons in their electronic configuration, except helium. Helium atomic number 2, electronic configuration 1s2. It has only 2 electrons. While coming to neon, atomic number 2, 1s2, 2s2, 2p6. Outermost shell, it has totally 2 plus 6, 8 valence electrons. 8 valence electrons. Similarly, argon also has 8 valence electrons, and krypton also has 8 valence electrons, and radon also has 8 valence electrons. And except helium, all noble gases has 8 valence electrons. Now we are going to see for different elements how the octet rule has been divided. For example, first, example 1, CO3 2 minus. For this molecule we are going to represent in Lewis form. First we need to locate central metal atom. See here, CO, carbon and oxygen. In this central metal atom is carbon, and most electronegative atom is oxygen. Between carbon and oxygen is more electronegative while compared to carbon. So carbon is less electronegative atom is written in the center, and more electronegative atom that should be written by side. And number of valence electrons in oxygen. Oxygen electronic configuration 1s2, 2s2, 2p4. Number of valence electrons 2 plus 4, 6. We need to represent as in dots, totally 6 electrons, 2, 4, 6, 2, 4, 6. It has totally 2, 4, 6 electrons. To satisfy octet, still it requires 2 electrons. That 2 electrons will be given to the carbon through this oxygen, like this. Here oxygen has totally 6, 3 oxygens also has 6 electrons, and carbon it has 6 electrons. To satisfy octet rule, it requires 2 electrons. that carbon gets from this oxygen. Totally it has 2 plus 2 4 electrons, 6 8 electrons it has. Now just represent in bond form. C carbon, one bond is equal to 2 electrons, totally 2 bonds, 4 2 bonds 4 electrons. Here 2 electrons means 1 bond, oxygen, and the charge which is present on the compound should be written upon the brackets. In this form we are going to represent Lewis representation for a molecule. Example 2, NH3. Here nitrogen is an central metal atom. Nitrogen, we have 3 hydrogens. Nitrogen atomic number 7, 1s2, 2s2, 2p3 electronic configuration. Total it has 5 valence electrons. One hydrogen will have one electron, one pair of electrons. Nitrogen requires still 2 electrons, that it will get as lone pair. One lone pair. In this manner we represent ammonia in Lewis form. Next one, Lewis dot structure. Lewis dot structure. Now we are going to write Lewis dot structure means number of electrons should be written in dot form. For example, carbon. It has totally 6 electrons and mass number 12. We represent like this in Lewis form. In Lewis dot structure, we represent it as dots. Okay, now for first example, H2, one hydrogen, electronic configuration 1s1, another one 1s1. We know that S orbital has spherical in shape. One hydrogen, another one hydrogen, it has spherical in shape. 1s1, both has 1 each electron, and the bond formed in between is covalent bond in this manner. In this manner we represent. This is the Lewis dot structure for hydrogen molecule, H2 molecule. Second one, O2. Electronic configuration 1s2, 2s2, 2p4, 1s2, 2s2, 2p4. Totally it has 6 valence electrons. S shell, S orbital, and oxygen. Totally it has 6, 4, 6, and the bond formed in between is covalent bond. this oxygen donates 2 electrons to form a double bond, and this electron donates 2 electrons, and another one oxygen donates 2 electrons to form a coordinate bond, that is double bond, that is pi bond. This is how Lewis dot structure of oxygen molecule has been formed. Next we are going to learn bond angle, bond parameters we are going to learn. In that bond angle, hybridization. Bond angle means the angle which is present in between two adjacent bonds. For example, in water molecule, the bond angle which is present is 105 degree. Bond angle means the angle which is present in between two adjacent bonds is called bond angle. Next, coming to hybridization. Hybridization means mixing of different atomic orbitals of different shape, energy, size to get a new orbital. Is called hybridization. Hybridization means mixing of different atomic orbitals. For example, sp, df are the orbitals. We are going to mix sp orbital. We are going to get a new orbital which will be different in energy, shape and size. That is called hybridization. For example, if the hybridization is sp3, we will expect tetrahedral geometry, tetrahedral shape and geometry. If the hybridization is s1 orbital and p3 orbitals, 3 electrons, the shape is tetrahedral. In this manner, we are going to define hybridization.